Okay, so we turn our attention to a different sort of trig equation. We end up getting negative root 3 cot y equals 1. Do we even know where to begin here? Cot, what even is that? We seen it before?
That's the bench thing.
It's a, so what this guy is, this is a reciprocal. It's a reciprocal trig function, and the reason why it exists is it's a simpler way of writing something that looks a little bit more complex. There are 3 reciprocal trig functions upon our vanilla trig functions. Open it, just go that way, please. The 3 reciprocal ones are, you have CSC, theta, we have sec, theta, and we have cot, theta. And all of these simplify one of our trig functions, or our vanilla trig functions. I use the word vanilla because they're our stock standard. The first one, CSC, this stands for cosecant. Sometimes people write it as cosec theta. But basically this guy simply means 1 over sine theta. The next one, secant, is simply 1 over cos theta. And the final one, cotangent, is 1 over tan theta. Now you're probably thinking, man, I got to remember 3 more things and how they relate back to the other, or our vanilla trig functions. And there's an easy way to remember this. Have a look at the final letter of the 3 reciprocal trig functions. How does the final letter of secant relate to its reciprocal function? Foreman?
C relates to the secant cosine.
Bingo. The final letter typically lines up with the first letter of the vanilla trig function. The only exception to the rule is cosecant, so CSC, or cosec. The way I remember this is I just remember it's the odd one out. And based on that, I've never been able to forget how the reciprocal trig functions line up ever since I was in year 11. So that's how I would personally recommend thinking about these. Now the next question is, well, if we know these, how can we use them to simplify equations like this? Well, it's reasonably straightforward. What we do is we arrange our equation in such a way that our reciprocal trig function becomes the subject. In this case, it's cot y, and then it becomes negative 1 over root 3. Then, cotangent of y is simply the same as saying 1 over tan y. And if we do the inverse, that's really messy. If we do the inverse of both sides of the equation, or do what I like to call a boss flip, then we can get tan y on the left-hand side is equal to negative root 3 on the right-hand side. Then it's simply a matter of asking the question, Where is the output of tangent? Negative. To do this, I draw myself a diagram. Could be off to the side, could be in the middle, it doesn't matter. I just always draw a diagram because it makes it simple. Then I know it's all silly turtles crawl, or all stations to central, and I ask myself, where is tangent negative? Well, it's negative in the second quadrant. What is it, Nick?
The second quadrant.
What was your mnemonic you were saying?
I don't know. Some turtles always crawl or something like that.
All some turtles crawl.
Yeah, something
All
like that.
silly turtles crawl.
That's the one.
All stations to central. Theta is going to be pi minus our interior angle
I
phi.
got taught all students take calculus.
All students take calculus, brilliant. And then our second theta is 2 pi minus our interior angle phi. And from there we just calculate those two solutions. First solution, whoops, is going to be, well actually no, we need to get phi, our interior angle. So that's going to be the inverse tangent of root 3, because we just pretend it's positive. And what is the inverse tangent of root 3? Pi on 3. So therefore our first solution is going to be, oops, y equals pi minus pi on 3. So that's going to be 2 pi on 3. Second solution is going to be two pi minus pi on 3. So that's going to be 6 pi's on 3. Take pi on 3 is 5 pi's on 3. Therefore, your y is going to be 2 pi on 3 or 5 pi on 3. And if you wanted to capture every possible solution, because I neglected to put a domain in here, then you can say plus 2k pi, 5, oops, or 5 pi on 3, plus 2k pi, where k is just some integer. Sound cool, guys? The only difference to this is now we're using the reciprocal trig functions, which are simply just 1 over the vanilla trig functions. The reason why we do this is it allows us to write quite complicated trig equations or expressions in a highly condensed form, so it's easier to digest. Does that sound cool? So it's basically last lesson, but with these 3 new functions to work with. So